All right, let's dive into one of the topics in trigonometry that can feel a little tricky, graphing those complex-looking sine and cosine functions. But I'm going to show you how to turn what looks complicated into a super simple step-by-step process you can totally master.
So, you see this equation on a test or in your homework. Yeah, I get it. Your first reaction might be, whoa, what is that? All those letters, A, B, C, D, it kind of looks like alphabet soup, right? It can feel pretty intimidating.
But stick with me here, because I promise you, by the end of this, you're not going to see this as a problem. You're going to see it as a set of instructions, like a recipe. We've got a foolproof plan to break it all down.
So first things first, let's deconstruct this equation. The best way to understand something is to know what all the pieces do. This whole thing is controlled by just four main characters, A, B, C, and D. Let's meet them.
First up is A, and A is for amplitude. This one's pretty easy to remember. It's all about the height of the wave. Think of it like a volume knob. A bigger A means a taller, more dramatic wave that stretches further up and down from its center.
Next, we have B. B controls the period of the wave. That's how long it takes to complete one full cycle before it starts repeating. Now here's the one kind of weird thing you got to remember. B is inversely related to the period. That means a bigger B value actually squishes the wave horizontally, making the period shorter.
Then there's C, which stands for the phase shift. Honestly, this might be the most important piece for getting started because it tells you exactly where your graph cycle begins. It's your horizontal shift. It literally picks up the whole wave and slides it left or right along the x-axis.
And finally, our fourth parameter is D. D sets the midline. You know how a basic sine wave just bounces around the x-axis? Well, D picks that whole thing up and moves it vertically, either up or down. The line y equals d becomes the new center of your wave's universe.
So here it is all in one place. This is your cheat sheet. A is for amplitude, that's the height. B affects the period, that's the length or speed. C is the phase shift, your left-right starting point. And D is the midline, your new up-down center. Every single thing about the graph is controlled by these four values. Okay, so we know the players, now it's time for the game plan. This is the four-step method that's going to work every single time, for any sine or cosine function they throw at you.
Here's the whole strategy. Step 1, just identify your A, B, C, and D from the equation. Step 2, you draw your framework. That means the midline plus the upper and lower boundaries for the wave. Step 3, you calculate the 5 key x values that will define one perfect cycle. And finally, step 4, you plot those points and connect them with that classic wave shape. It's a system, and it works.
Theory is one thing, but let's actually get our hands dirty and see how this master plan works in practice. We're going to do a full example, from start to finish.
All right, here's our function. Take a good look. We're going to apply our 4 steps directly to this equation. Let's get to it. Okay, step 1. Identify the parameters. Right away, we can see A, our amplitude, is 3. B, the number affecting the period, is 2. C, our phase shift, is pi over 4, and D, our midline, is 1. Easy enough. It's also really nice that the B value, that 2, is already factored out of the parentheses for us. That makes finding C super easy.
On to step 2, the framework. We start by drawing our midline, D, which is at y equals 1. Now, since our amplitude, A, is 3, we go up 3 units from the midline to find our maximum value at 4. Then we go down 3 units from the midline to find our minimum at -2. Our entire wave is going to live inside this channel. Step 3, this is where we find our key points on the x-axis. First, let's find the period. The formula is 2 pi divided by b. Since b is 2, our period is 2 pi over 2, which is just pi. Now here's the secret to making this easy. A sine wave has 4 distinct parts. So we divide our total period of pi into 4 equal chunks. That gives us what we call a quarter period of pi over 4. This is our magic number. So how do we use that magic number? Well, we start at our phase shift, C, which is pi over 4. That's our first key point. Then we just keep adding our quarter period. So pi over 4 plus pi over 4 gives us pi over 2. Add it again, we get 3 pi over 4. Add it again, we get pi. And one last time gives us 5 pi over 4. And just like that, we have the 5 x-coordinates that define one full cycle of our graph.
And now for the finale, step 4. We know the x values, but what about the y values? Well, since we're graphing a sine function, it follows a simple, repeatable pattern. Midline, then maximum, back to midline, down to minimum, and finally back to the midline. So we just plot our 5 points following that pattern, draw a smooth curve connecting them, and boom, you've graphed it. Now, a quick but really critical warning. This is probably the #1 mistake people make. If your equation isn't already factored, like if it said sine of 3x minus pi, you must factor that b value out first. If you don't, you'll get the wrong phase shift, the wrong c, and if your starting point is wrong, every single point after that will be wrong too. Always factor b first.
So you can graph a sine wave. But why should you care? Well, it matters because the world all around us is just filled with cycles, and these equations are the language we use to describe them.
Just think about the average temperature in a city over a year. That's basically a sine wave. The midline, D, would be the city's average yearly temperature. The amplitude, A, is how much the temperature swings above and below that average between summer and winter. The period, of course, is 365 days. And the phase shift, C, that just tells you what day of the year is the hottest. Suddenly, A, B, C, and D aren't just letters. They're describing our actual climate.
And that's really the key takeaway here. A, B, C, and D are not just abstract math concepts. In the real world, they represent actual, physical, measurable things. They turn this wavy line on a graph into a powerful tool for modeling everything from sound waves and ocean tides to cycles in the economy.
So the next time you see a pattern that repeats itself, whether it's the hours of daylight in a day, a kid on a swing set, or even the rhythm of your own breathing, ask yourself, how could I model that with a sine wave? What would A, B, C, and D represent? Because once you start looking for it, you'll realize this math is absolutely everywhere.